Good morning, everyone. Welcome to another great day of learning some geometry. Today we're going to start into Chapter 1, Section 5, and here we're going to be talking about pairs, so two angles that work together to do something special. We're going to talk about a couple of different pairs here in Section 5. Let's see what those different pairs are. Let's get them all right here at the beginning. Our first one is adjacent angles, and adjacent just means next to. Sometimes you might talk about a street or a house that is adjacent to yours or to where you are. Things that are adjacent just mean next to. But specifically in geometry, we say if angles are adjacent angles, they are two angles with a common side, so that means they share a side, and they have a common or share a vertex. And if you remember, a vertex is that corner of the angle, that point at the corner. So right here we have pictures with two different pictures of adjacent angles. Angle 1 and angle 2 are adjacent angles because they share that side right there. There's that common side or shared side, and they share the same vertex or corner. The corner of angle 1 and 2 are both that point right there. 3 and 4 are also adjacent angles. They share that side or that ray, and they have this point here as their vertex. Since they share a side and they share a point, share a vertex, that is an adjacent angle. Our next one, and this one's going to pop up a lot more than adjacent angles, is vertical angles. Vertical angles are going to pop up a whole bunch throughout the rest of this semester. So vertical angles are two angles whose sides are opposite rays. Really what that means is it's two angles that are formed by two lines that cross. So when you see two lines that cross each other, like in this picture right here, two lines just going all the way through them, two lines crossing each other, vertical angles are going to be the angles that are opposite of each other in that case. So angle 1 and angle 2 are vertical angles with each other. Angle 1 and angle 2 are vertical angles because you have two lines crossing each other, and 1 and 2 are on like opposite sides of that x, left and right. We could also say that angle 3 is a vertical angle with angle 4. Angle 3 and angle 4 are vertical angles with each other because they are also formed by two lines crossing each other, and they're opposite of each other. Top and bottom are opposite. So 1 and 2 are vertical angles, and 3 and 4 are vertical angles. Now, like I said, vertical angles are going to show up a bunch, and the reason why they show up so much and why they are so important is because of this. Vertical angles are always going to be congruent to each other. So since we said angle 1 and angle 2 are vertical angles, I can also say angle 1 is congruent to angle 2. Now, that is great, but if you don't remember what congruent angles means, that might not mean too much. Remember, if two angles are congruent, that means that their measures are equal. So if we somehow knew that angle 1 was maybe 30 degrees, we would automatically know that angle 2 is 30 degrees as well because they're congruent. They have the same measure. And that would mean that 3 and 4 are congruent and therefore have the same measure as well. That's why when I was marking them, I marked 1 and angle 2, each with one arc, saying that they're congruent, and 3 and 4 each got 2 arcs. Since they each have the same number, that means they're congruent as well. All right, our next angle pair is complementary angles. Complementary angles are not angles that are free, and they're not angles that tell you that you look nice today, even though that would be super cool if they did. Complementary angles are angles whose measures have a sum of 90. Remember, sum means add up to. So this is any two angles that measures add up to 90. They don't have to be next to each other. They can be, but they don't have to be. Any two angles that add up to 90, any two angles whose measures add up to 90 are complementary angles. So right here, angle 1 and angle 2 are complementary because they together make this 90-degree angle. They together make a right angle, add up to 90. Okay? Remember that box means 90 degrees. So angle 1 and 2 in this picture happen to be complementary and also adjacent angles. In this picture, they also give us angle A and B. They are not right next to each other, so they're not adjacent. A and B are not adjacent because they don't touch or share anything. But if we do 47 plus 43, that's 80, carry the 1, 90 degrees. Since their measures add up to 90, angle A and angle B are complementary angles. They add up to 90. Supplementary angles. Supplementary angles are similar to complementary, but rather than adding up to 90, they add up to 180. So if you have two angles that add up to 180, that makes them supplementary. Supplementary 180, complementary 90. That's something you're just going to kind of have to memorize. That's our vocabulary here. Mr. Renneker and I talked about vocabulary being very important, and this is one of those cases. Complementary is 90, supplementary is 180. So here, 3 and 4 are supplementary because together they make a straight angle, a straight line, 180 degrees. We also have a picture here with a 137 degree angle. So if we did 137, and let's grab angle B and use it again, B and C. So if we do 137 plus 43, that's 180 degrees. So B and C are also supplementary with each other because together they make 180 degrees. All right, so let's just do a little bit of practice. We want to name a pair of vertical angles. So a pair means I have to have two different angles. So I'm going to write angle, leave room for some letters, and angle, I'll write the other letters. So I need to find two lines that cross each other. So right here I see one line and another line crossing each other. So now I need to pick angles that are opposite of each other, like maybe angle CFD, this angle here, angle CFD, and angle AFE. Remember, when naming an angle, you want to use three letters, and the middle letter has to be the vertex. One thing you notice for these vertical angles, they have the same vertex. That's always going to happen for vertical angles. But that's not the only vertical angles we have in this picture. So this is one answer. That's great. But another answer, you could have done angle EFD, angle EFD, and that would be a vertical angle with angle CFA. So you could either have this top line as your answer or the bottom line. You don't need both. I just wrote two pairs, just for a little extra practice. Now this asks for a pair of complementary. Complementary means they have to add up to 90. So as soon as I see complementary, I need to think 90. So I'm looking for two angles that add up to 90. Well, I only have three different measures. I don't have any of those little right angle boxes, so that's not going to help. So from those three measures, I need to find two that when added together give you 90. Well, this already is more than 90 by itself, so that's not going to help. So let's do 68 plus 28. If we do 68 plus 28, 62, sorry, it says 62. If I do 62 plus 28, it is 90. So because 62 plus 28 is 90, that means those two angles are complementary. So now I need to name this 62 degree angle. Remember, F is its vertex, so that has to be the center letter. I start here on A to F to E, so angle A, F, E, and that is going to be complementary with angle, the 28 degree angle here. Again, F has to be the middle letter, but I start on C, go to F, go to B, so angle C, F, B is a pair of complementary because they add up to 90. Next, it asks for a pair of supplementary. Supplementary means I need to add up to 180. All right, so I already know that these two added up to 90, so it can't be those again. This is a nice big angle, so I'm going to add that up. So let's try 118 plus 28. 118 plus 28, not 180, so I don't like that. Let's try 118 plus 62. There we go, 180. So the 118 and 62 work out. So I can name angle AFE again, angle AFE. FE, that's the same name because I'm talking about that same 62-degree angle, and I need this big angle, the 118, angle EFD, angle EFD. All right, last question on this slide is, what is the measure of angle CFD? CFD is this angle right here. Now, it doesn't say anything about its measure, but if we look back up here in the first one, I said that CFD and AFE are vertical angles. If they're vertical angles, that means they're congruent, which means their measures are equal. So since AFE was 62, the measure of angle CFD is also 62. Since they were vertical angles, they are congruent and therefore have the same measure. All right, this last one here is another vocab word, not as important, but linear pair is a pair of adjacent angles, so they have to be next to each other, whose opposites or whose other sides make opposite rays or form a straight angle or a straight line, which means that any linear pair has to be supplementary, because if they're a linear pair, they're going to be supplementary because they make a straight angle, 180 degrees. So let's see how this works out right here. We have two angles that are a linear pair right here, okay? It says the measure of KPL, this one right here, 2x plus 24, and the measure of angle JPL is 4x plus 36. What is the measure of each angle? Since we know that this is a linear pair, we know that together they add up. We can say the two angles together add up. So that's one angle plus the other angle. They have to add up to 180. When we know it's a linear pair, you take the two pieces, add them up to 180, because a linear pair has to be 180, a straight line. Like Mr. Renneker has said in the past, he does left plus right equals the whole thing. So we do left plus right equals the whole thing as a straight line. So left plus right equals 180. And now we can combine our like terms. 2 plus 4 is 6x. 24 plus 36 is going to be 60 equals 180. And now we start to solve it out. 6x equals 120. Divide by 6, and we have x equals 20. So I know that x is 20, but am I done? I have to go back up here and look. No, they don't ask for x, they ask for the measure of angle KPL. So the measure of angle KPL, I have to take 20 and plug it in right here. 2 times 20 is 40. 40 plus 24 is 64. They also ask for the measure of angle JPL. So I take 20 and plug it in right here. 4 times 20 plus 36 gives me 116. So there's my answers. If I want to check to see if those make sense, I can add them together and they better equal 180. So 116 plus 64 is 180. So I feel pretty good about that answer. All right. Last vocabulary word here is an angle bisector. An angle bisector is anything that cuts an angle into two congruent angles. Anything that cuts an angle into two congruent angles is an angle bisector. So right here we have an angle and it's cut into two congruent parts because each piece is marked with a little arc. So this bottom and the top are the same. We can say that those two pieces are congruent to each other. That is an angle bisector. If you've ever done a dissection in science class, dissect, you've cut it apart, and bi, like a bicycle, means two, so it's to cut in two. All right, last slide here. We are trying to name any pair of vertical angles. So to find vertical angles, I need to find two lines that cross each other right there and there. And we just name opposite angles. So I'm going to say angle AFE and angle CFD. There are more answers than that, but that is one of them. To find complementary angles, I need to find two angles that add up to 90. And I see right here a right angle mark and two angles together making that right angle mark. So I can say angle AEF and angle DEF. Because together they make up that 90-degree angle. This piece, the left plus the right, equals the whole thing, and that box tells us that it's 90. So therefore it's complementary. To find a to find a linear pair, we need to find two together that make a straight line. So I find a straight line. This straight line right here looks pretty good. So I can say angle CFD, this angle right here, and the other half of that straight line is this angle over here, angle EFD. Again, there's more than one answer to that, but this one is just fine. And the very last one doesn't actually have anything to do with that picture, so I'm going to draw one. It says PB bisects angle RPT. So here's RPT. Remember, P, the middle, has to be at the vertex. And it says some ray PB, we're just going to draw PB, bisects it, it cuts it in half. And it says that the measure of RPB, this one right here, is x plus 2. And it says the measure of TPB, this other one down here, is 2x minus 6. Now remember, bisect is kind of like the midpoint. Bisect is going to cut it into two congruent pieces, just like a midpoint did for a segment. So bisect does for angles what a midpoint did for segments. So we can just set these two equal to each other. X plus 2 equals 2x minus 6. Add 6 to both sides and get x plus 8 equals 2x. Subtract x, and we find that 8 is equal to x. So we know that x is 8, but it doesn't ask for x, it wants RPT. So we have to find RPT, that's the whole thing. So I'm going to take 8, plug it back into both of these. If I plug in 8 here, 8 plus 2 is 10, so this top part is 10. If I plug 8 in here, 2 times 8 is 16, 16 minus 6, this piece is 10. And I like that those are the same answer. But now to find the whole thing, I do left piece plus right piece equals the whole thing. 10 plus 10 equals 20 degrees for our final answer. All right, that's it. I hope you guys have a good day.